What was part 3?
Find the value of t when particle reaches maximum.
Find t when particle is max height. And what do you reckon we might do there, Em?
Y dot equals 0.
Yeah, easy, right? So let y dot equal 0. What's that? Angus, let y dot equal 0 for me. How are we going to solve? Y dot equals, yeah, for max height, yeah? So, like, again, with these ones, they typically give you different steps along the way. So they're going to give you this guy. Even if you can't get it out, you can use it. Like, that's the most important thing I can tell you with these multi-part questions, that they usually give you a way to help you out. Yeah, good. Yeah, let's do that. So 0 is equal to 1 on k. I should say for max height here. So for max height. So 1 on k, ku sine alpha plus g, either minus kt minus g. Well, get rid of the k.
Hell yeah.
Oh yeah. Yeah, it's pretty good actually. It's not too bad of a question.
Yeah, it's nice. This one's a nice one.
Yeah. So would you say get the g to the other side?
Get
Get. What are you trying to pronounce it as? But oh, get it.
And it goes to the top. Yeah. No, just a negative.
Oh, okay, sure. Like that?
Yeah.
Sure. Okay. So divide by that, then remove the negative power. Okay. Ku sine alpha plus g. What else can we do? What are we trying to actually get? T, right? So, wait. Oh, right. Wait.
Yeah, and then divided by g.
Okay, that's a plus. I thought that was a D for a second. I was really confused. Divide by G. Okay. All right.
Plus 1. I guess. And then log water.
All right. So log of both sides. And then almost there. Yeah. Let's go. T is equal to 1 on k. ln ku sine alpha on g plus 1. Is that what you guys got? What did I get?
I didn't do the plus 1 because it's too lazy.
Part 3. Oh yeah, right. I put it under a common denominator. Sorry, that's not very good. Part 4. What was part 4? Oh, that was the one you asked me before. Limiting. Find the limiting. What was it? Find the limiting value of the horizontal velocity or something. Horizontal displacement.
Displacement, yeah. Is that like the line there, the asymptote?
Yeah, I guess. I guess so. Like when you think of. When you think of what that really means, find the limiting horizontal displacement. What does that mean in the context of projectile motion?
How far it could be. Like if I want to go below the axis.
Does that look like angles wrong?
Yeah, I think there's a few things factored in with that, hey. Because we can adjust the angle, we can adjust the initial velocity.
So create on further.
As x approaches because basically what it's implying, like when you think of the word limiting, like you mentioned in advance, we think about as, like I think what's the sort of maximum value for x in terms of the horizontal value itself. And it makes more sense when you actually get the expression for x, right? So do we have an expression for x dot that we can use somewhere? Do we have that? What was x dot?
Oh no, just U, no negative.
U cos alpha. Is that it?
Yeah.
Okay, cool. So yeah, and it'll be clear why there's a limiting value in a moment, right? So if we take integral both sides. I guess we go with respect to t, right? So we're going to get x is equal to, now you can use the integration tricks here or the plus c or whatever you prefer. That should be in, so that's just a constant. So then we can put the negative there. I think that's it. Plus c. Sorry?
Just divide by k?
Divide, sorry, yes, you're right. Divide by k and put a negative out there. Cool. That fine? Very good? Yep. And then at t equals 0, wrote dt. At, write it again. At t equals 0, x equals 0, so is that the origin? So 0 is equal to negative 1 on k u cos alpha e to the 0 plus c. So c is equal to that. And then so x will be equal to negative 1 on k u cos alpha e to the minus kt plus this guy, which is then, if you factorize it out, we can factorize out u cos alpha 1 on k. So 1 on k u cos alpha. We just get left with, well, this is positive 1, right? And this is minus e to the minus kt, so that. And so remember when I said like, oh, limiting values, but they're kind of actually expressions because we don't have the initial velocity or the initial angle, right? If you think about what this is graphically, the limiting value will be determined as t is approaching infinity. Right, what is my x approaching? What's the biggest value my x can really get? 2.
Not selling any values into your calculator.
Yeah, well, put it in. But, you put it in your calculator, right? You're right there. What was that? Yeah, okay. You're getting a really confused look. So, have I lost you or very good? No. Okay, cool. Well, in some solutions, I've seen them actually when they do the integral, they do it from like 0 to infinity or something, right? But I think what that really means is that they're saying, yeah, sub in a really big value here, right? And when you like just do this part, if you sub in a really big value for this, just have a look at what you get. Or yes, you can do your transformations of your exponentials. So if you remember what this guy looks like. Do I have Desmos up on here? Desmos. Think about what this looks like. Like normally you have your exponential going like this, right? But then you have now, you're reflecting it in the x-axis and also the y-axis, right? So you're actually doing 2 reflections. And so it's going to look like this. So as t approaches infinity, what's this guy going to approach eventually? This graph. So like, this is your normal, sorry, pretty bad exponential. Usually you have your exponential looking like this, right? But you've got a negative in both respects. So you've got negative as a coefficient, you've got negative in the power. So you're going to be doing 2 reflections. You're reflecting in the x-axis and also the y-axis, right? And then so, yes, this is actually going to be approaching to 0. And so, yeah.
So limiting value is 1.
Yeah, so the limiting value will be, did you? Sorry, I didn't catch that.
No.
You said a lot of things, so I was a bit confused. So as t approaches,
Like the whole thing in the bracket approaches 1. Because like if that thing is approaching 0, then like the whole bracket thing, right?
Mm.
So,
Oh, is that what you were saying? Sorry, I thought you were saying this is approaching
Sorry,
the
yeah,
1.
sorry.
Because then that would be 0. I'd be like, oh,
Yeah,
x approaches 0? How does that?
I'm doing this hard when I'm towards the next one.
All right, cool. And then, so that's your limiting value. And that's why I was a bit confused because like, oh, it's a value, but u cos alpha. Yeah, there's no number. There's literally no numbers in there. How is this a value, right? So that's just how they phrase this. Right? That was an HSC question, 2003, I think. Cool. That's further projectile motion. Have we got that other question there for you? I'll have some ready for you on Wednesday.